What you're about to hear is a story about rats, but stay with me, because it ends with an ocean. Picture a small tropical island, white sand, swaying palms, the kind of place a travel brochure would weaponize against your savings account. From the outside, it looks like paradise, but something is deeply, silently wrong. The trees are too quiet, the skies are almost empty, and under the water, just a few hundred meters offshore, a coral reef is slowly starving. Nobody poisoned it. Nobody dumped chemicals. The culprit? A rodent the size of your fist, and scientists are only just now untangling exactly how much damage it caused, and how jaw-dropping the recovery looks when you take it away. This is the story of one of the most unexpected chain reactions in modern ecology. Step by step, domino by domino, from a rat-free island all the way down to the seafloor. Buckle up. Nature's about to make you feel things. So, first things first, how did rats even get onto these islands? Over the last several centuries, people introduced rats to many tropical islands through settlement, sailing between islands, and shipwrecks. You didn't even need to try. A ship runs aground, a few stowaways scurry ashore, and suddenly an ecosystem that evolved for millions of years without a single land-based mammalian predator has one. Thousands of them, and they are absolutely ravenous. Here's what makes rats so catastrophically effective as invaders. Rats are a very damaging invasive species, consuming the seeds of many plants and devastating bird populations as they eat eggs, chicks, and even adults of the smallest seabird species. They don't discriminate. They are opportunists with fur and an attitude problem. Until recently, rats on Ulong Island in Palau were so abundant they were regularly seen during the day. They were a nuisance to campers and deadly for wildlife. Daytime rats. That's not a horror movie. That's an ecological emergency. And this brings us to the first domino, the one that starts the whole chain, the seabirds. When rats colonize an island, seabird populations don't just dip. They collapse. As opportunistic omnivores, rats readily prey upon seabird eggs and chicks, devastating nesting colonies on tropical islands. As a result, there were very few nesting seabirds to be found. Think about that. Entire species of birds that had been nesting on these islands for millennia, gone, or barely clinging on, because of one introduced predator. The skies go quiet, the cliffs empty out, and most people looking at that island would never know what was missing because they never saw what it looked like before. But scientists knew, and they had a bold idea. What if you just removed the rats? That's exactly what happened on Ulong Island in Palau in the Western Pacific. Island conservation, the Koror State Government, and the Koror State Rangers worked together in 2023 and 2024 to remove the introduced damaging invasive rats which had devoured native bird eggs and young decimated native plant populations through seed predation, preyed on native crabs, and disrupted food webs. It was a meticulous, carefully planned operation. And then they waited. What happened next stunned even the people who designed the experiment. Freed from rat predation, seabird activity on the island surged, not slowly, not gradually over years, fast. Bridled tern calls rose by 286%, while brown noddy and white tern calls increased by roughly 50% compared to the control island Ngaruk Tabel, a nearby similar island where invasive rats remained present, 286%. That's not a recovery, that's an explosion. The skies over Ulong went from near silence to a full-blown seabird party, and it happened within a single year. Now here's where it gets really interesting, because most people would stop the story here and call it a win. Birds are back. Great. Conservation success. Roll credits. But the scientists kept watching. And what they found next is where this story goes from cool to absolutely mind-bending. Here's a question for you. Before watching this, would you have guessed that removing rats from a small island could change what's happening on the seafloor hundreds of meters offshore? Comment your answer below, because the answer is about to flip everything you thought you knew about how ecosystems connect. Now, let's talk about bird poop. Yes, bird poop. This is the secret weapon that nobody saw coming, and it is the hinge on which this entire story turns. Seabirds feed on fish, often in the open ocean far from islands, and then return to islands to roost, depositing nitrogen-rich nutrients on the island in the form of guano. They are, in the most gloriously unglamorous way possible, biological conveyor belts between the open ocean and island ecosystems. They fly out hundreds of miles, gorge themselves on fish, come home, and essentially fertilize the island with the concentrated nutrients of the deep sea. It's a nutrient pipeline that evolution spent millions of years engineering, and rats shut it down. When the birds came back to Ulong, the guano came with them. And then the rain did what rain does. Some of the guano is leached off the islands by rain and into the surrounding seas, where the nitrogen fertilizes corals and other marine species, such as algae and sponges, boosting the food chain. The island was essentially running a natural fertilizer delivery service direct to the reef, and researchers could measure it. Leaf nitrogen on Ulong rose by approximately 80%. The soil was visibly, measurably richer. The nutrients were moving. The pipeline had reopened. This is the part where the story leaps from the treetops into the ocean, and the payoff is staggering. Indicators in the water around Ulong moved in positive directions. Fish biomass increased, and coral cover showed gains compared with the unchanged control site. The researchers link these marine responses to the restored flow of nutrients from seabirds on the island, which can fertilize nearshore waters and support food webs. Let's put a number on that because numbers matter here. Researchers found fish biomass increased significantly once rats were removed. One location recorded a 183% increase, nearly triple the fish, from removing rodents from the land. Increased nutrients in the water also appear to be supporting reef-building coral. The reef wasn't just surviving, it was beginning to thrive. And here's the kicker that the scientists themselves couldn't quite believe. The team had expected such improvements to Ulong Island's ecosystem would take decades. Its coastal recovery at a speed that has surprised even the scientists behind it. The model said, wait 30 years. The island said, give us 12 months. This research is the world's first experimental study demonstrating that seabird recovery following invasive rodent removal drives nutrient transfer from land to reef, confirming prior observational findings that restored islands benefit their surrounding ecosystems. And Ulong isn't alone in this story. The pattern holds across oceans and decades. On Tromelin Island in the Indian Ocean, rats were eradicated in 2005. Since then, there has been an 8-fold increase in seabirds, and 6 species that were locally extinct because of the rats have restarted to breed. 6 species, back from local extinction just because the rats left. And on nearby Ile du Lys, where rats were eradicated in 2003, surveys show there has been a 10-fold increase in seabirds since. 10-fold. The birds were always ready to come back, They just needed the rats gone. Research across the Seychelles added another layer to this picture. Scientists found that through seabird-derived nutrient uptake, algal turf grew more quickly, which led to an increase in both the mass and productivity of herbivorous fishes, beneficial to reefs. This feedback loop between producers and consumers actually limited the amount of turf algal cover on reefs, keeping the reef clean, balanced, and functional. The birds weren't just feeding the reef, they were regulating it. There are even hints that the nutrient boost could help corals fight back against the climate crisis itself. These naturally derived nutrients can even help corals recover faster from coral bleaching events. The re-establishment of natural nutrient subsidies provided by seabirds could possibly lessen the impacts of marine heat waves that can cause coral bleaching and death. Think about what that means. At a time when coral reefs worldwide are under siege from warming oceans, one of the most powerful tools we might have is a small furry animal we already know how to remove. And it goes even deeper. Research shows that black rats disrupt a nutrient pathway provided by seabirds, ultimately altering the territorial behavior of coral reef fish. In a replicated ecosystem-scale experiment, reef fish territories were larger, and the time invested in aggression was lower on reefs adjacent to rat-infested islands compared with rat-free islands. The fish weren't just fewer in number, they were behaviorally different, hungrier, more spread out, less productive. The rats on land were changing how fish acted underwater. That is how connected these systems are. That is how far a single domino can fall. Other work shows that seabird-derived nutrients create hotspots of marine primary productivity that attract megafauna like manta rays. The recovery of seabirds can restore critical connections in a meta-ecosystem, linking the open ocean to islands to coral reefs. Via the movement of nutrients across ecosystem boundaries, we're not just talking about more fish, we're talking about manta rays, about entire ocean food webs reorganizing themselves because birds came back to nest on an island. The scale of this is almost hard to hold in your head. So, what's the lesson in all of this? It's this. Ecosystems don't have neat borders. The land and the ocean aren't separate stories. They're the same story, told in different languages. When you break one part of the chain, the damage doesn't stay put. It travels, it compounds, it shows up somewhere you'd never think to look, like on the body of a reef fish 300 meters offshore. And when you fix one part of the chain, even one small, unglamorous part, like removing rats from an island, the healing travels too, faster than anyone expected, farther than any model predicted. Getting rid of the rats is likely to benefit terrestrial ecosystems and enhance coral reef productivity and functioning by restoring seabird-derived nutrient subsidies from large areas of ocean. It could tip the balance for the future survival of these reefs and their ecosystems. One small island, one targeted intervention. Seabirds return, guano falls, rain carries nutrients to the sea, algae blooms, fish multiply, coral grows, manta rays circle. An entire ecosystem breathes again, and it started with getting rid of a rat. Nature doesn't need us to build it something new. Most of the time, it just needs us to get out of the way and occasionally to fix the one thing we broke. If this story blew your mind the way it blew mine, hit subscribe because we are just getting started on the wildest chain reactions in the natural world. And trust me, the next one is even more unexpected.